Today I will explain you about basics of electrical resistance. Electrical resistance in simple terms means opposition or blockade or to prevent. To understand it more easily, I will play a short video of a young boy running on two different surfaces. What do you observe in these videos? When he runs on a tar road, he can run swiftly and faster, while when he runs on seashore sand, he struggles to maintain the same speed. As a result, his speed slows down. What is the reason behind? It is the surface on which he runs. The surface offers resistance which determines his speed. Similarly, when electric current flows through a conductor, it experiences resistance. There is opposition for the flow of electric current. Electrical resistance opposes the flow of electric current in an electric circuit. If the resistance of the conductor is low, electric current can easily flow through the conductor. While if the resistance of the conductor is high, less current flows through the conductor. Examples of resistances used in electrical laboratories. These are called rheostats. Electrical resistance is defined as the property of a conductor to oppose electric current. It is represented by R capital. Its unit of measurement is ohms, symbolized as omega. The unit ohm is in memory of a German physicist and mathematician Sir George Simon Ohm. How to calculate end-to-end resistance of a conductor? If you have a conductor of length L and cross-sectional area A, then the end-to-end resistance of the conductor is calculated as R is equal to rho L upon A, where L is the length of the conductor and A is the cross-sectional area of the conductor. Rho is the specific resistance, which is a measure of how strongly the conductor opposes the flow of electric current through it. Its value remains constant for individual material. Resistance is directly proportional to the length of the conductor. That is, as the length of the conductor increases, the resistance also increases, and inversely proportional to the cross-sectional area of the conductor. That is, as the diameter of the conductor increases, resistance decreases. While you decrease the diameter of the conductor, the resistance increases. How to calculate the resistance in an electric circuit? In a simple electric circuit shown, a voltage of V volts is applied to a lamp of resistance R ohms. This results in a current of I amperes flowing through the circuit. Now here, apart from electrical resistance, you come across two more electrical quantities, that is voltage. Now voltage is represented by V and is measured in volts, while electric current is represented by I and measured in amperes. To calculate the value of the resistance, we use Ohm's law formula, that is R is equal to V upon I, symbol of electrical resistance. Electrical resistances in electric circuits can be either represented as fixed or variable. If the resistance is fixed, we cannot change the value of the resistance in the circuit. But in case of variable resistance, the resistance can be either increased or decreased in the circuit while the electric current is flowing through it. Electrical resistance determines two categories of materials. One category is called conductors and the other category insulators. So what are conductors? They are those materials which offer very low resistance to the flow of electric current, or in other words, conductors allow electric current to flow through it. Lower the resistance of the conductor results in lower voltage drops. Mostly all metals are good conductors of electricity. The metals gold, silver and copper are excellent conductors of electricity. Wires are not drawn of precious metal, that is gold and silver, but still contacts of relays are electroplated with this metal wherever required. Wires are mostly drawn of copper and aluminium. Insulators are those substances which offer very high resistance to the flow of electric current, so that practically no current flows through them. Some common insulators of electricity are PVC. PVC stands for polyvinyl chloride, used in PVC pipes, PVC switches, coating of wires, etc. Rubber. Rubber is used in rubber mats or rubber gloves. These gloves are mostly used by electricians while handling electrical repair work. Porcelain. Porcelain is used for fuses, bases of switches. Bakelite. It is used for covers of old switches, panel boards, etc. Glass. The outer covering of lamps is made up of glass. Electrical resistance is measured by instrument called ohm meter. Other instruments that are used to measure electrical resistance are multimeter and megger.